Good morning students, welcome to your chemistry class. Let's start with the discussion of the chapter Organic Chemistry, and in that we are going to cover alkanes. So what are the objectives of the chapter? First of all, we are going to study its introduction, then we are going to cover its sources, isomerism in alkanes, and we are going to do detailed study of methane and ethane, and in that we are going to study its occurrence, laboratory preparation, other methods of preparation, properties of methane and ethane, and uses of methane and ethane. Our objectives of today's topic will be introduction to alkanes, sources, isomerism. Then in detailed study, we are going to cover up occurrence, laboratory preparation, and other methods of preparation. First of all, we should know what are alkenes. So alkanes are saturated hydrocarbons containing carbon-carbon single bond in their molecules. The other name of alkanes is paraffins. Why they are known as paraffins? Because alkanes are relatively unreactive under ordinary conditions. So for their reactions to take place, we want a higher temperature, sunlight or diffuse sunlight. So there are certain conditions necessary if we want them to react. Students, we should also know general formula of alkenes, that is CnH2n plus 2, where N is number of carbon atoms. So if N equals to 1, that means the formula will be CH4. If we substitute N value to be 1, if one carbon is present, the root word is meth, and since all are single bonds, so ene, so the name is methane. If N equals to 2, that means the molecular formula comes out to be C2H6. Therefore, the name comes ethane, because for 2 carbons, the root word is eth, and since all are single bonds, so therefore it is ethane. Likewise, for 3 carbons, it is propane. For 4 carbons, it is butane. And it is very simple for us to calculate its molecular formula if we know the general formula. So what is the general formula of alkanes? CnH2n plus 2. The next thing that we should know is sources of alkanes. The first source is natural gas. What is natural gas? This gas is actually obtained under the earth crust. So underground it is obtained, and maximum proportion of natural gas consists of methane, that is 77 to 92%, and the rest are in small proportions, ethane, butane, propane. It is an inflammable gas, so mostly we are using that only. The second one is petroleum. So from natural gas and petroleum, we can obtain alkenes. The next topic that we are going to study is isomerism. To understand isomerism, let us take example of C4H10. Now for this, first of all, count the number of carbon and hydrogen in both the cases. In first case, when you count, there are 4 carbons and 10 hydrogens. And same is the case with the second one. There are 4 carbons and there are 10 hydrogens. But what we are finding is that the molecular formula is same, that is C4H10, but the structure is different. Okay, so the structural formula is different and the molecular formula is same. Such a phenomenon is known as isomerism. So what is isomerism? Isomerism is the phenomenon in which compounds have same molecular formula but different structural formula. So how the isomer is formed? The terminal position carbon with its CH3 comes to the middle position, and the hydrogen of the middle position shifts to the terminal position, and likewise the valency of carbon is also satisfied and the isomer is also formed. Next example, let us take of pentane, that is, now we will be drawing the isomers of pentane. For this, there are 3 isomers. So different structures can be drawn with the molecular formula C5H12, and their names are as follows. First of all, we will be drawing an open chain compound with 5 carbons. Then the terminal carbon atom with its CH3 will be shifting to the middle position like this. Done. Afterwards, the middle position hydrogen will shift to the terminal position and satisfy the valency of this carbon. Open chain pentane, it's been known as, and when the carbon from the terminal position shifts to the second position, then it is known as 2-methyl butane, since the longest chain consists of 4 carbons. Now the next one is, since when we see this middle carbon, it's one of the valencies still satisfied with the help of hydrogen. So what we can do? We can pick up this terminal carbon with its CH3 and we can place here, and the hydrogen can shift accordingly at this position, and it gives rise to this structural formula. One single carbon in between and 4 carbons are surrounding it, and their valencies are satisfied with the help of hydrogen. Now where the one carbon is surrounded by 4 carbons, this is also known in the common language as neo. Okay, NEO. It's known as neopentane, but the IUPAC name is 2,2-dimethyl-propane. Longest chain consists of 3 carbons, and on the second carbon there is a substituent, and that is being at the second position, so it comes out to be 2,2-dimethyl-propane. Next, we are going to study occurrence of methane and ethane. The first one is that they are available in marshy areas, that is wet, waterlogged areas near the river. So methane is a major constituent of marshes, and that's why methane is also known as marsh gas. The second one is that they are obtained from the air exhaled by animals whose food contains cellulose, like western cattle, sheep, pig, humans, etc. The third one is it is obtained in intestinal gases as well. The fourth one, the occurrence of methane and ethane, is from the fire dams, that is coal mines, the gas available in coal mines. From there also we can that's also a source of methane and ethane. The fifth one is dry distillation of wood and coal. When wood is being heated at 450 to 500 degrees Celsius in the absence of air, then also methane is formed. Now the next topic that we will study is structure of methane. So methane, the formula is CH4. Carbon is a non-metal, hydrogen is also non-metal, so it is a covalent bonding. Okay, and it is arranged in a tetrahedral form, that is 4 bonds are arranged in a tetrahedral form, so it is having a tetrahedral geometry. Same way in case of ethane, 2 tetrahedrals are joined together. So this carbon, there are 3 hydrogens attached to the above position, one of the dimensions, there is another CH3 that has been attached. So 2 tetrahedrals are joined together in the ethane structure, but the bonding here is covalent. Okay, so now let's start with the lab preparation of methane. For preparing methane in the laboratory, you have to use CH3COONA, that is sodium acetate, and the IUPAC name is sodium ethanoate because there are 2 carbons in the structure. That will react with NaOH, that is sodium hydroxide, in presence of calcium hydroxide, and it will give rise to methane, that is CH4 and sodium carbonate. From this sodium acetate and sodium hydroxide, COONA plus NaO, they will merge together and it will form sodium carbonate as the byproduct. Methane, it is having CH3. CH3 is coming from the alkyl group present in the salt. So if we want a higher member, supposing we want C2H6, we are going to use C2H5 here. Ethyl group will be used here. Now NaOH and calcium oxide, the two together are known as soda lime. Why we do not use only sodium hydroxide? Why we are using the combination? Because sodium hydroxide is deliquescent in nature. It will absorb moisture. So therefore, to avoid that, the mixture of NaOH and CaO is used. Okay, for this heat is also required. Temperature about 300 degrees Celsius is required. That's why a burner is being placed. Then both the chemicals react together and they are being collected by downward displacement of water. Similar case how ethane is formed. Now as I already discussed, if you want a higher member, you will be just changing the alkyl group from the salt. So you are taking C2H5COONA, that is sodium propionate, plus NaOH in presence of calcium oxide and 300 degrees Celsius temperature. You will be getting sodium carbonate and ethane formation. How the gas is being collected? As we have already discussed, it will be collected by downward displacement of water. Why it will be collected so? Because it is slightly soluble in water. We can also use the word insoluble in water or sparingly soluble in water. That's why it is being collected over water and the displacement is downward. We should also know other methods of preparation of methane and ethane. So the first one is from idomethane. Idomethane means meth means one carbon, ane means all singly bonded, and the one of the valencies of the carbon is being satisfied with the help of iodine. In this, we also use zinc and HCl because when we react zinc with HCl, it produces nascent hydrogen. So the nascent hydrogen will react with methyl group to form methane, and one of the nascent hydrogen will react with iodine in iodomethane and form hydrogen iodide. The next is from aluminium carbide. As you know that aluminium's valency is +3 and carbide's valency is -4. So by reacting together, they will form the formula Al4C3 plus 12 waters, and it will give rise to methane and aluminium hydroxide. So by using aluminium carbide also we can prepare methane. The next one is by using Wood's reaction. In this, we can prepare higher member alkene. If we have something related to one carbon, we can get a higher member alkene of double the number of the hydrocarbon. So for this, what you are doing is you are reacting alkyl halide. Alkyl group means CH3 and reacting with the sodium atom. So two molecules of alkyl halide reacting with sodium metal in presence of dry ether give rise to NaI as a byproduct and ethane gas is formed. If you want butane as the product, in that case you will be using ethyl iodide. You can use any halogen like ethyl iodide, ethyl chloride, ethyl bromide, etc. And that will be reacting with sodium metal in presence of dry ether as the solvent. You will be getting butane. So students, in today's lecture, what you have studied? You have studied that what are alkanes, then you have studied their structure, isomerism, then how they have been prepared, and then the different methods of preparation as well. Thank you so much.